with a damaged LCD connector. So what we want to do is we want to replace it real quick. Because we're not going to reuse the connector, we can heat it from the top. If we were taking the connector from a donor board, it's ideal to heat it from the bottom. That way you do not melt the plastic that is part of the screen connector. So because we are not going to reuse it, that's why we are heating it from the top. Now, the connectors, in terms of getting a connector that will work for this, so connectors from 2012 MacBook Pro up until 2015 can be used. MacBook Air connectors from 2012 up until 2017 can be used. Now, this board is a 2017 board. The board number is 820-00165. And by the way, 820-00165, the 2015, and 2017, they share the same board number. The difference, however, you will spot it's the 2015 is going to be the processor will be 1.6, and the 2017 is going to be 1.8. So that is out. We now want to clean the section to prepare it for a replacement. So another thing we also want to do is we also will be checking the health of our fuse, because we see the damage was particular on the section of, or the line of the backlight line. So we will also be checking that to be sure that our fuse it's still intact, it's not broken. If it's broken, we can either replace it or put a tiny wire across the fuse. Let's prepare the pad. Get some flux. Sodium lead. The backlight output pad doesn't look great. So what I will be doing is I'm going to be checking for continuity, just to be sure that we don't have a breaking line on the backlight output pads. I'm going to show you guys shortly what I mean by that, and yeah, just okay. That's pretty much prepared, and just let me show you guys what I mean by that. Quickly open the board here. This is it is 0-00165. Where are you? Okay, here you go. This is the connector. Now, what I mean by so this pads here, which is 3 and 4, I'm supposed to get a continue. So when I measure at pin 3, 4 to this cap here and this cap here, in continuity mode, I should get a beep. So what I'm going to do is I'm going to place my multimeter, put it in continuity mode. So what I want to do is I want to place, because I just want to be sure there is no breaking line between this and that. Because if that's the case, what's going to happen is you just have a voltage that is being produced but not being consumed by your screen. So let's put it into continuity mode. Let's see if we have continuity. We can use this cap here, can be used. So we do this and then we do this. Okay, let's see that, this. Okay, let's just send to okay, let's just confirm from a donor board real quick. 1.9. Okay, pretty much good enough. Seems to be same. Let's see that again. Okay, that's pretty much seem to be fine. So what we now want to do is wanna grab another board to get the connector from. See if we can get a MacBook Air. And by the way, we can, okay, we can as well use a 2011. This is a 2011 connector. If you look at the difference, you see, I don't know if you guys can spot the. So this is the connectors that was used 2011, even 2010 uses it, and this is what I decided to use from 2012. See, the color is slightly different. I'm not sure if you guys can see that. We can use either of it, not a problem, but we're just going to use this. So because we will be reusing this, so what we want to do is we want to take it from the other side. We want to take the connector from the other side, not from the top. Uh, so we do this. Take the connector from the bottom, and I try not to keep my hot air in one phase, I mean in one spot, so that I do not create damage to the components below it. I can as well take the connector from the top, but then I have to distance the hot air uh, pretty much from the connector, and obviously that takes a whole lot of time, and not just that, I will be very careful not to damage. Yeah, I don't want to. Let's just take it from the bottom, and yeah, it's quicker, it's safer, yeah, and you will have the connector also intact in that method. So we have a couple of repairs that's going to be going off in line after this. This is kind of like a quick repair. Okay, it's yeah out. Now to install it, we can use two methods to install it. We can just solder it directly, or we can just do the same way we remove that. We can install it the same way, which is place it and then hit it from the bottom, and yeah, pretty much the same way we took it out. We can put it back that way as well, or we can use a soldering iron. So let's do that. Install it the same way we took it out from a donor board. Let's remove this paper. Don't worry, it's going to be aligned. It's not aligned yet, but yeah, it's going to be aligned. That's not a problem. It's going to fall in line real quick. Okay, yeah, that's pretty much what we want it to be. Okay, that's pretty much how we want it. If you guys can see, it's gonna look really good on the side. I don't know if you guys can see that. See, so I may not even need to use. Um, yeah, it looks good. Let's see the other side. So that is the other side. You see, our components is still intact on the other side. We just need to remove this. We'll clean the board, test it, and then see what we have. Let's quickly clean that section where we worked. Clean the other side as well. So I was saying something about one of the ways. Um, if you look at this here, see here, it's going to say 1.8 GB, 8 gig on. So that can also give you an indication that this is a 2017 board. Yeah. So if it was a 2015, you have that to be 1.6. So the MacBook Airs, the 2016 line is skipped. So you will have 208, 209, 2010, 2011, 2013, 2012, 2013, 2014, 2015, and 2017. So there was no 2016. So that is pretty much skipped. 2016 was pretty much skipped, so you will not find a 2016, but you will find a MacBook Pro 2016, but MacBook Air 2016 you won't find. 2015 and 2017, they use 100% identical logic boards. However, the configuration, the CPU configuration is definitely going to be different. Like I said, one you have 1.8. That's one of just like an easy way to spot it. 1.6, 1.8. How many machines did Marco bring in today? How many? The one they were looking for, is it there now? You want to clean your section where you worked. Very important. So now let's check the health of the fuse that's on the board. Be sure the fuse is fine. Continuity mode. Let's see what we have. Fuse fine. Just check that again. Is the fuse fine? Yeah. So as expected, the fuse is blown. So what we will do is we can choose to replace it. At the same time, we can choose to put a tiny wire across it. I'm just also going to show you guys how to do that in case you don't have a fuse. You can. So you see, like I said, I anticipated, the line that was affected was the backlight. The backlight parts, particularly this was damaged. So what would usually happen in this case would be that the backlight fuse will blow out, which is as a protection to the circuitry, because it detects a short in that line. This is our fuse here. So now the fuse is blown. The connector has been replaced. We need to replace the fuse because the fuse is blown. We can choose to replace the fuse, and or we can choose to put a tiny wire. So, but just for this repair, we want to put a tiny wire. Just so for the guys that in case they're doing a repair like this and they do not have a replacement fuse, you can also do it in this way, which is just put a tiny wire across it, and you will be just good to go. Now, just please note that when a repair, when it comes to using wires, the wire to use on a fuse, given the specification of this fuse, has to be really really tiny. You want to make sure you're having um, the same concept of what the fuse is supposed to do, which is when it detects any type of potential risk to the logic board on the section of the backlight, you want the fuse to basically cut out. So if you put a wire that is too big, what will happen is you will have a damaged circuitry because the fuse is just going to remain, and it's not going to. You want it to cut out. You want the fuse to cut out. You don't want the fuse to remain when there is a potential damage. So what you want to do is want to quickly put a wire across it. So this you can use this method, and when you do not have a fuse to replace with. In our case, we do have plenty of fuses, but we just want to do it just in case you come across an issue like this one, and you do not have. So I'm just going to put a bit of solder on each side, and then you can put a wire across it. Okay, solder on each side. And where's our wire? Okay, it's really tiny. Here, this is our wire. Put it across it. Okay. Mm, it's better to always use a fine tweezer because you get a better grip. Struggling with it with my tweezer here. And also, do not make the mistake of putting a solder block across it. No, that's also risky. You want to put a tiny wire across it so that when there is a need, the wire will break easy. Okay, so that is put in place. What we now want to do is we want to see if our fuse is fine now. It's on both sides. Okay, fuse is fine. Let's make sure we don't have a short on the other side. The other side. Okay, we don't have a short. Now we want to quickly clean that up. Test our screen to be sure we have image as well as backlight, and then that will be the conclusion of the repair. Okay. Can I have a fan? Let me have a MacBook Air fan on Peter's desk. So again, what? Oh, Macwave. Oh, it's end of the month. Oh, yeah, please. I completely forgot that those people are even supposed to pay us. Yeah. So right now we want to let's see if we have image as well as backlight. Just something just something that I want to show you guys here. So when you look at this connector, for example, you see the clip. You see this, I don't know if you guys can sense that. So when you see there's a difference in color here, all of up until this point. Now, this is a coating that Apple put in place. This is amazing. This is a coating that Apple put in place. Why did they do that? Because if there was no coating, when you clip the connector like this, let's say when you clip the connector like this, and then you close the clip, what's going to happen is you will have a bridge. So this will, because obviously because it's metal, it's going to create a bridge here. So what they had to do was they had to put a coating from this point to that point. So even though when this sits on it, there will be no basically bridging taking place. That's a wonderful thing. So that's something that yeah, Apple engineering, it's really good what they do. So now let's see. Do we have fan spin to start with? Yeah, we'll have a fan spin. And now let's wait to see if we have image or are we going to have a blown out fuse. We did check for a short already. We don't have a short, so it's fine. Okay, that's a reaction. We have a screen detection. Now we want to see if we will have a flashing folder. That is if we have backlight. Oh, okay. No, we do not have backlight. So we have image but no backlight. So we want to find out why that is. Image but no backlight. Okay. So now let's see what we have on our backlight outputs real quick. So I'm not sure if you guys can see a question in my folder. I'm just gonna put a screw on the fan so that can you see it? Yes. Uh, can I have a screw? Okay, let me see if I can grab one here. Okay, what you want to do now is you want to say you say you can see the flashing folder. Okay, so what you want to do now is you want to see what you have on our backlight output. So that will determine what we need to do next. First and first, okay, yeah, let's see what do we have on our backlight output. Okay, let's say that backlight output seem to be that's 40. So what's happening now? This is exactly what we feared. This is why. So yesterday I was talking about no load. So this circuitry, the backlight of this machine is going to generate 40 volt at max. Now 40 volt at max. So when we measure, we talked about this yesterday. So when we measure at the backlight output here, what do we see? Are you able to capture that? So we have 40 volt. Now 40 volt tells us that the backlight is being produced, but the screen is not. There is no load. The screen is not. It's not putting any load on the backlight. That is why it's full at 40 volt. Now, the one thing that what we feared. So we need to establish that there is a connect that there is a continuity between the pin 3 4 and 831.7 up until let's say yeah, then through our diode here. Now and also ensure that there is no break. Okay, now let's try to resolder, kind of like put a joint between this and that and see what we get. So right now we have backlight being generated, but we are sitting at 40 volt, which means there is no load on there's no load from our screen on the board. So let's see if we can rectify that, and then we test again. So that was exactly why I was trying to establish a continuity between this and that the first time. But Yeah, so what we want to do is, I'm not sure if you guys can see this. Let me show you guys something. Here, the lighting. Uh, Here, Peter, can you say this? Can you capture this? I can say it, but I'm not sure if you guys can say it. So what I want to do is I want you to scratch out this a little bit, and then I'll put a solder blob here, and then that should solve the issue. So what that will do is I'm trying to establish the link that's been broken from. So let me just I'm just gonna scratch that out just a little bit. I'm trying to reveal the pad to use, and I'm gonna put a solder blob there. That should solve our issue, and we should have a functioning backlight. Okay, so now if we look at that, so between the pins, the good thing is you have unconnected, unconnected. This is also amazing because the backlight, if you look at 3 and 4, that's a high voltage line. So what Apple did was they had to create a separation between them because just after that pin is ground. Just after that, no, on this other side, after that, it's ground. So obviously, if this was put just in place of that, I mean, that's going to be really, really bad. So just go. So in between that, you have non-connected and unconnected. So also what that means is we don't really have to worry about um, bridging anything. But nonetheless, what we want to do now is we want to put a solder block right across so as to create that line to become healthy, and we test again, and then we should have image at that point. Also, what we want to do is we want to make sure it's really tiny, not so much so that the screen can close easy. I'm talking about the clip so that the clip can easily lash in place. Uh, let's do that. Let's clean this up. A bit of flux. Okay, just gonna do this so that we get enough room. Okay, I have a solo grabbing face. That's two. Two, one, two. Okay, let's now let's see what we have now. Hmm. Right now, we're not going to clip it. We're just going to test it first, and then we can do the clipping later. Let's see what we have. Do we have backlight, or do we still have to remake it? Okay, fine. It's spinning. Let's wait. See, do we have image? Okay, we have image, and that's it. That's backlight. So now, if you check, oh, by the way, this is an updated firmware because the firmware before now, the Apple logo will only come up when you have a boot part. But with the updated firmware of Apple, even without a boot part, so what happens is you see the Apple logo, even though there is no drive there is no drive. So the next phase of this is going to be the Apple logo will show up, and then you either get a flashing folder or a loading bar. But in this case, obviously, that's a flashing folder because there is no drive. This is the space of the drive. There's no drive. So now let's see what we will find on. Remember the first time what we were having 40 volt. That's because the voltage was produced and there was no load on the screen. Now let's see what we have. Black probe to ground. Now let's see what we have on our backlight output. What do we have? That's it. Now we have 24 volt. I don't know. Does that make sense now? That tells you because 24 volt. Now that tells you because we have load on the screen. So with load on the screen, then you will have the voltage will obviously drop because of the load you have on the screen. So that marks the completion of our repair. What we're going to do is we will just clean up that section and make sure this will close, the latch closes nicely on the screen connector, and then the machine can be put together. The test that's required to be run will be done, and then the machine will be finalized. Thank you guys. See you on the next video.